In this video, we're going to talk about how to calculate the integral of a general exponential function. So suppose that you have an exponential function that takes this form, a to the box d box by dx times d box, and don't worry too much about what this means. We'll talk about how this all works in just a second. But anyway, if you have a function a to the something, okay, then the integral of that is going to be a to that same something divided by ln a plus c. Okay, and then this right here is the exact same thing, it's just a different symbol. But we're gonna explain what this is with a couple of examples. So let's start with one right here. So let's say you have a function f at x, we'll call it, is equal to 2 to the power of 3x. And then the question asks you to find, okay, find this, the integral from the interval 1 to 2 f at x dx. So right away, whenever you see that interval, you know that what they're asking for is for you to find the definite integral. Okay, so that is the area underneath this curve here from the interval 1 to 2. So what we're going to do first off is, as you can see here, the integrand, okay, so that's everything after this integral here, has to take this form before you can convert it to this right here. Now, as you can see over here, this would be our integrand. But what we're going to do is we're going to set our placeholders first. Okay, that's the first thing that we need to do. So let's set our placeholders. So what is this box here? What is going to be this placeholder? As you can see, a is going to be 2, and 3 to the x is going to be our box. So let's do that. 3 to the x. And then the derivative, okay, so d box by dx, the derivative of that box with respect to x, so the derivative of 3x is just 3. So d box by dx is equal to 3. So there's our first step. Now what we're going to do is we're going to manipulate this integral to give us what we want. So what it's asking for is what is 2 to the from the interval 1 to 2, 2 to the power of 3x dx. Okay, that's what this question is asking for. What is that integral? But before we can convert it to this, okay, to get our answer, we need to put it into this form right here. So what we can do is we can now use our placeholder. So I'll put from the integral 1, the interval 1 to 2, and then 2 to the power of this box dx. Now the next thing we want to consider is it's still not in this form yet, right? Because we want to be differentiating with respect to box, not with respect to x, since we're putting in our placeholder. So what we're going to do is we're going to go here, write this integral again. Okay, so 2 to the power of our box times the derivative of the box with respect to x dx. And the way you can think of it is these two dx's cancel out, and now it's in a proper form because you're going to be differentiating with respect to this placeholder here and not with respect to x. So if we were to substitute those numbers in, we would get this. So we would get the integral from the interval of 1 to 2, 2 to the power of 3x, and times, okay, this d box by dx, which in this case is 3, times 3 dx. Okay, so now as you can see, it is in this form for integration. Now we can go ahead and integrate it. Actually, not yet. Because as you can see, even though it's in the proper form, this does not equal our initial form here, right? Because of this 3. So what we can do, okay, this does not equal this expression. So what we can do is we can make this 3 cancel out by adding a 1 over 3. So 3's cancel, and now this entire thing is in this form. So the next sleight of hand we're going to do now is take this 1 out of 3 out. Okay, the next trick we're going to use to make sure this integral works for us is to take the 1 over 3 out of the integrand, and so that we have this. So we have the integral from 1 to 2 times 2 to the power of 3x times 3 dx. Now we are ready to evaluate this integral, because as you can see here, that this entire expression, okay, this entire expression is equal to our original expression here. So it doesn't change. The expression hasn't changed. But even better is that this, the integrand, is in this form here. Okay, it's in the form we can integrate in, which means now we can just go ahead and convert it to this form here. So what that means is this will equal 1 over 3, the multiplier constant, okay, this, times this integral, which is going to be this, times a to the whatever that box is, so it's going to be 2 to the power of 3x divided by ln of 2 plus c. And then we can write from the interval of 1 to 2. Okay, see how that works there? And then what we can do is we can go ahead and further simplify this, make it look a little bit nicer. 2 to the 3x divided by 3 ln 2 plus c. And again, I go from this, from the interval of 1 to 2. And then from here on in, we can just plug our numbers in. So what that will be is it'll equal 2 to the power of 3 times 2 over 3 ln 2 minus, okay, and actually, you know what, we don't even need this plus c here, okay, because it's a definite integral, so we can, the plus c will cancel out, so we don't need that. We can just leave that as is. Minus 2 to the 3 times 1 divided by 3 ln 2. Okay. And then if you put that into your calculator, actually I'm just going to simplify this, so 2 to the power of 3 times 2 gives us 64. 2 to the power of 3 is just 8, minus 8, divided by 3 ln 2, and that'll give us an answer of about 26.9. Right? And so that is the definite integral for that function.